Hello! So this is the first lecture of the course Game Theory, and all the formalities, how you register, what exactly are the requirements and so on, they are on the website. You are welcome to contact me if required. So now let us directly get into the material. Well, not so directly, because this lecture is going to start with an overview of game theory and what are its major sub-disciplines, and then we are going to get into non-cooperative game theory, which is an important sub-branch, one of the major sub-branches of game theory, and we are going to zoom in and to look at this non-cooperative game theory, because the first part of the course will actually dwell on that. My name is Gleb Polevoy, and the lecture, as I said, is going to be an introductory lecture. Now, we're also going to study some fundamentals upon which game theory is based, such as utility theory, and we are going to also put the theory into context. So, what it uses, which parts it has, and so on. Now, naturally, that's not what we are going to engage with during the course, but naturally, context is important. So, both to just know why we are studying and to understand things better, and to hopefully choose which topics you would like to study or to work at in the future. So please enjoy this unusual, relatively to the rest of the course, but nonetheless important lecture. So we will start by an overview of the theory. Then I'm going to give a short account on its branches. So, what are the sub-disciplines? Of course, I'm not going to be able to mention all the sub-disciplines, even of game theory. It's not all math, but even game theory is huge. So it's not. I'm not also aiming at naming all its possible subdomains, but I'll give you a decent impression, and I'm also going to look at how people approach various questions, and then we are going to look at one important theory, which actually it kind of grazes with psychology, maybe a bit behavioral economics. So it's something upon which game theory is based, but it's not game theory per se, utility theory. However, it's extremely important, and not for nothing that von Neumann and Morgenstern, the founding fathers of the modern game theory, they did provide a model and a theorem which we are going to cite, so not prove here, about utility. So that's an important question, and that's definitely something which is crucial. And then, after having seen the major part of game theory, we are going to dwell into one important discipline, which is going to be our major business in the first part of the course. I think it's going to be the largest part even of the whole course, which is non-cooperative game theory. That's basically when we analyze the general idea models of some agents. They have some behavioral strategies, and they gain something or lose. And so this is a very general model, classical, important, nice to start with, relatively simple. And that model has inside several ways to model interactions, which we call games. So the model is called a game. And naturally, it's not that we model only games, so we can, but we model any interaction we would like to. And the classical models, we're going to get a glimpse at now are strategic or normal form, that's the same, games, extensive form games, and finally succinct forms, several succinct forms, just a short kind of a short, you may say, detour into succinct games. We are not going to get busy with succinct games during the semester. It's going to be just a little bit. So mostly we are going to work with strategic, a little bit with extensive games, and that's it. And we're also going to talk about how we can convert from one representation, so for example from strategic to extensive forms. Okay, so first an overview of our nice, wonderful game theory. I forgot to tell you that it's wonderful. I hope that you have managed to gather that it has to be wonderful, otherwise I wouldn't be giving a course on it. But if you haven't, or if you have forgot, so please take notice. That's definitely wonderful. So game theory is roughly spoken mathematical analysis of interaction. So we would like to analyze interaction when you have two or more parties, people, companies, countries, ants, whatever, interact, or software entities like programs, for example, or whatever. We can analyze that using mathematics. That's basically game theory. Now, that's naturally something which is basically, it's the mathematical basics of economics. That's definitely the case. It's a little bit like math and physics are related, so game theory plays the role of math in that tandem, and economics plays the role of physics, being a bit more practice oriented. It's not exactly the same, but you may at least from one point of view say that's the